Hello friends, welcome you in my YouTube channel. Today in this video, I am going to talk about organometallic compounds. You know friends, this topic is very important for chemistry people. So let us start with organometallic compounds with the hope this video will be beneficial for you. Chemistry of compounds containing metal carbon bonds. In many complexes, both sigma and pi bonding exist between the metal atom and carbon. Types: sandwich complexes, cluster compounds, and carbide clusters. Now, J's compounds or salts. The organic molecule is attached to the metal via the pi electrons of the ethylene ligands. Compound with CO Mond purifications of nickel. The big boom in organometallic chemistry, synthesis of kerosene, began the era of modern organometallic chemistry. Friends, organic ligands and nomenclature. A number of ligands may bond through different number of atoms. The number is indicated by eta followed by a superscript. Kerosene contains the penta-heptocyclopentadienyl ligands. Hepto means to fashion. Do a few others like the 18 electrons rule. Total of 18 valence electrons on the central atom. There are many exceptions. You can see here chromium, CO, eta and manganese compounds and N3, C5, N5 this compound. In general, hydrocarbons ligand come before the metal. You see HMCO5, the metal is in the first row. 18 electrons represent a field valence shell for a transition metal. Why do many complexes violate the 18 electrons rules? The answer of these questions: the 18 electron rule does not consider the type of bonding and interactions. The interactions between the ligands and the metal need to be identified to determine if the complex will obey or violate the 18 electrons rule. This statement will also identify pi in many cases. Now friends, interactions between the ligands and metals. Examine the MO diagram for chromium carbonyl. This includes the interaction between the d orbitals and sigma donor pi acceptor orbitals of the 6 ligands. Understand this diagram in terms and strength of the different type of interaction. 18 electron is the most stable for this type of complex. Assuming the d orbital to be at similar energy levels, which complex would you predict to be the most stable? Complexes that possess ligands that are both strong sigma bond donor and pi acceptor should be the most likely to obey the 18 electrons rule. How about ligands that have different donor and acceptor characteristics? Ethylene diamine is a sigma donor but not as strong as C. What effects does this have on the diagram studied previously? The zinc ethylene diene complex is stable. How many electrons? How about titanium Cl6. It has 12 electrons. Can you justify this with an interaction diagram? Square planar complexes, 16 electrons. The ligand is a good sigma donor and pi acceptor. Understand the interactions and influence on stabilization of the complex. The 16 electrons square planar complex are mostly encountered for the metals. Oxidation states of the +2 are common. Examine the frontier orbitals HOMO and LUMO. Synergistic effect sigma donor and pi acceptor. Spectroscopic evidence bond lengths are vibrational frequencies. How will the interaction diagram appear for a binary octahedral compound? HOMO, these will have the same symmetric characteristic as py orbital previously. So LUMO, these will have the same symmetric characteristic as px py orbital previously considered. So you can see the HOMO diagram. So bridging modes of CO. CO can also form bridges between two or more metals. Position of CO stretching mode. Why is there a general decrease in frequency with increasing metal centers? So most binary carbonyl complexes obey the 18 electrons rule. Why? Why doesn't vanadium CO6 form a dimer to obey the 18 electrons rule? The tendency of CO to grease transition metal decreases going down the periodic table. Why? So friend, oxygen bonded carbonyls. Occasionally CO bonds through the oxygen atom in addition to the carbonate. So attachment of a Lewis acid to the oxygen weaken the CO bond. So ligands similar to CO, CS, CAC, CN and nitrogen. CN is able to bond readily to metal having higher oxidation state. CN is a good sigma donor but a weaker acceptor, cannot stabilize metal of low oxidation state. So no NO complexes. Hydride complex, only a 1s orbital of suitable energy for bonding, must be a sigma interactions, minimum basis set. You can see dihydrogen complex, just salt. What are the types of possible interaction? What happened to the HS bond? So friends, ligand having extended pi system, linear pi system, ethylene, allyl, N1,3-butadiene, cyclic pi system. So bonding between ethylene and metal, sigma donation pi acceptance. If orbital of appropriate symmetry are present, isoluble. Appropriate symmetry are present, we call it isoluble, and interaction may occur. Construct an molecular orbital diagram. Pi system trihapto ligands. So cyclic pi system, you see eta 1, eta 3, eta 5 bonding modes. Kerosene orbital on ligands and metal can interact if they have the same symmetry. The strongest interaction is between orbitals of similar energies. What is the point group? Let's give it the treatment. You see. So friends, adduct to the oxygen of osmium tetroxide. Complexes in which the fullerene itself behaves as ligand and compound containing encapsulated metals. So fullerene as ligands. Cis-T behave primarily as an electron deficient alkane bond to the metal in a dihapto fashion through CC bond at the fusion of the two 6-member ring. What effect does this have on the two carbon atoms? can say. Fullerene containing encapsulated metals, cage organometallic compounds. So complexes containing MC double bonds and MC triple bonds. Grignard reagent, magnesium alkyl bonds and methyl lithium. Grignard reagents can be used to synthesize organometallic compounds containing an alkyl group. The interactions is largely through sigma donations. Metal containing only alkyl ligands are rare and usually unstable. Carbene complexes, Fischer type and Schroep type complexes. What are the differences between the two different types of carbene complexes? We have to focus on this. So, bonding in Fischer carbene complex, sigma donation and pi back bonding complexes is generally more stable if the carbene atom is attached to a highly electronegative atom. The electronegative atom participate in pi bond. Similar to a pi allyl system, can be represented as hydride structure. What type of spectroscopic evidence would show the existence of metal double bond carbon? Discuss the proton NMR of chromium. At high temperature there is one signal from the methyl protons, and low temperature there is one signal. Illustrate a compound type of bonding, sigma bond plus 2 pi bonds, neutral 3 electrons donor. So how you do the characterization of organometallic compounds? X-ray crystallography, infrared spectroscopy, NMR spectroscopy, mass spectrometry, element analysis and others. What is the IR spectra? The number of IR band depends on the molecular symmetry. Monocarbonyl complexes, dicarbonyl complexes, linears and bent. 3 or more carbonyl on the complex. We will assume that all IR active mode are visible and distinguishable. Terminal greater than W bridge greater than triple E bridge. Why? As pi acceptability increases, the CO stage decreases. As pi acceptability increases, the CO stage decreases. What may affect the ability to accept the electron's density into the pi acceptor orbitals? NMR spectra. Chemical shift, splitting pattern and coupling constant are useful in characteristic environment of atom. Carbon 13 NMR, proton NMR. Proton bonded to metals are strongly shielded and using spectroscopy for identifications. These are references. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.